I think so.
Yeah.
We're live streaming now.
Yeah, I just went live. Can you just see if the sound is fine?
So it's still running.
Yeah, it should. Sound. And so we should say that. I need to, is it okay that
Ask for the
Oh yeah.
Oh yeah. Yes. Well, I'm not going to have time to really give it to you. I think it's I'm not going to keep it. Yeah. I think this was far actually. I'm not doing it. We've got an application to see what trying to use. I think it's trying to use that possibly testing in space.
Do that.
Should we start? Bamdan, should we start or what? Or are we starting in 7? And I can see all the cool people are already here.
No,
we are due to start. Where is it?
So, welcome everyone. Happy New Year. This is going to be the first event in the 2013, and we have a bunch of other events this year. We have React Meetup next week here on 23rd, which engineers from Basho are coming and giving a talk about React. We have Lean Manchester Meetup here on 5th of February, which you can follow on hashtag LeanManC on Twitter. And we have a good news for girls. We have first ever Geek Girls Bar Camp in Manchester in March. And We have also quarterly briefing in March, ThoughtWorks quarterly briefing in March. So we have two good news that all of our Geek Nights are being recorded and live streamed. Since about 3 months ago, we are going to put them also on YouTube. So I will post the YouTube channel link to everybody who have registered on the Meetup group. Also, I would like to ask everybody who wants to hear about a specific topic from people inside the ThoughtWorks or anybody who you know can talk about this specific topic you're really interested and they live around Manchester. We would be really happy to host the events about technology here in Geek Nights. Please send tweet about Geek Nights on hashtag #TWUKNorth and hashtag ThoughtWorks. We would be really happy to hear about your feedbacks about the Geek Nights. We have Diptanu here. He has been in ThoughtWorks for about how many years?
I think it's 4 years maybe.
4 years, yeah. Yeah, thank you for coming.
Something to talk about the React meetup, right? Like I think the topic of React meetup is how hinted handoff works in React. It's around like how the cluster works in React and how when a node goes out, like how the node tells the other nodes that it is going out. So if you're into like distributed persistence or in that sort of thing, like it would be very cool. It would be a cool talk. And a Basho engineer is actually coming and giving the talk. So thanks. Thank you. I don't know if this works. We'll find out. My name is Diptanu, and I'm a DevOps consultant here at ThoughtWorks Manchester, and I'm into, as I said, into distributed persistence systems and system programming in general, and things like functional programming. So today we are going to talk about. I'm going to talk about continuous delivery and about like how to set up a continuous delivery pipeline, and with specifically Jenkins, Puppet, and Mcollective. And it's not going to be like a very philosophical talk. Most of the DevOps talk, like are centered around like change in culture and change in the way we think about software delivery and how we collaborate with others and to deliver software. That is a key theme of DevOps and is what it has been driving the movement for a very long time. And but this talk is not one of those, right? You are here, and I'm assuming that you already agree that DevOps is good, and that continuous delivery is good. So we are going to take it from there, right? So now that we know that CD is good and DevOps is good, right? Like, what are the next steps, right? So before I jump into like all the stuff that that we are going to talk about, the tools which enable us to make like a get into the DevOps bandwagon or the CD bandwagon. I want to know like how many of you have heard or like known what DevOps is, like just to know like okay. So a fair amount of people know about DevOps, and and I think can I assume that do you also know about CD? Like people who know about DevOps, like they have thought about CD. Okay, so for those of us here, like who haven't like really got a chance to talk or talk about DevOps, there is no empirical definition of DevOps. There is no dictionary definition of DevOps. I think DevOps is about raising the bar. Raising the bar of how we deliver software. And I was just telling Manish, DevOps is about like how we can, be awesome at delivering software. That's how I think of my job when I go to a client. Like it's about like, raising the bar up, raising, like thinking about how they are doing delivery and how they can change that to be more productive and to deliver faster and to deliver software without all the ceremonies of a Friday evening release or a Thursday afternoon merge, or going through like test managers or release managers. That's the way I think about DevOps. In case you want to know about CD in general, or understand what the philosophy of CD is, like what are the good principles of doing continuous delivery, my colleague Jay Sambal has written an awesome book. It's called Continuous Delivery, and it talks a lot about those bare principles which are very essential for doing continuous delivery. Things like version control, things like trunk-based development, things like a deployment pipeline. So he talks about the principles behind all that. ThoughtWorks also has a website called continuousdelivery.thoughtworks.com, and you will find a lot more talks around the philosophy of DevOps and continuous delivery. So just in a nutshell, like why we do want to do CD is because we want to reduce the risk of releases. We want to get software out of the door as fast as we can. And for me, like as an engineer, the third and the fourth points are very important, right? For me, what I've seen teams practicing or taking DevOps seriously, like it takes out the whole thing of, oh, okay, the software is running in this environment, but the bug that is reproducible in this environment cannot be reproduced in some other environments. While it can happen, even if you are like on the scale, on the fifth scale in the whole maturity model of DevOps or CD, it can happen because all environments are different. Like your production environment can have different heuristics than your pre-prod environments, because maybe there are more traffic which goes into your production environments. But I've seen like teams taking automation seriously, teams taking infrastructure automation very seriously. They reduce those number of variants that can happen in different environments. So you can hope to see a world where you take infrastructure automation very seriously, that everything looks very similar, right? There is no Diptanu, or there is no Nathan, there is no Manish. It's like all collective, right? We are talking about a collective of infrastructure. We are going to talk about what collective infrastructure means later on, and what it means to get out of application server 1 and LDAP server 2 and database server 5, right? Infrastructure are not people. Infrastructure, in my opinion, should be treated as collectives, and we will see like how you can achieve them. And this talk is going to outline some of those recipes that has worked for me to get to that stage in my journey. And also this other key thing is about thinking about what are the states in your system, right? We all know by principles that the best software out there are the ones which doesn't have state. The reason that HTTP is so great is because it's stateless, and that's why it can be so robust, right? But 99, not 99, whatever, like I don't know, like a lot of the software we write like has state, right? All the object-oriented programmers here, like I mean, I do OOPS as well. Their state is an important part of our software, right? A lot of system thinking makes us very hard to think about where does state belong in a system, right? If you have a web application, chances are very high that your state is in the session, right? Or chances are very high that your state is in your database server or something, right? Now, what happens when a server which goes down, which has all your sessions, right? What happens when the database server goes down, right? So, does your system continue to be live in that scenario? Probably not, right? But if you take systems thinking very seriously, if you take infrastructure automation and the whole philosophy of automating every single bit, you are automatically going to be thinking on those lines. What happens when 5 of my database servers goes down? How do I bring up new database servers? And what are the essential states of my system? And how do I give myself more, more like what happens like when something goes wrong and how do I deal with it, basically that stuff. Some of the first principles which has helped me. Again, this is not something that I'm going to claim that is going to work for you, but something that has worked for me and something that continues to work for me at this. A lot of us use CI servers, right? Like everyone, all of us use CI servers. Like CI servers are the backbone of our of our software delivery lifecycle. Every time we check in, stuff happens on the CI server. Okay, something like, yeah, I mean, more or less, right? Like, I mean, yeah, okay, fine. Let's assume that everyone uses CI server, right? Let's forget that, yeah. But I've seen at a lot of clients and a lot of people that people back up the CI server like crazy. Okay, like why are we, why, when I ask the question, why are we backing up the CI server again? Oh, all the builds that I did today are in the CI server, right? I need to back them up so that like if my CI server goes down, I don't lose all those builds. Now, seriously, like CI servers, Go or Jenkins or TeamCity or anything, like should be just your orchestrator, right? CI servers in the context of a continuous delivery pipeline, where you are saying that you want to deliver software with a pipeline, we will see like what pipeline means. A CI cannot be the the artifactory, or the CI cannot be the home where all your jewels live, right? The CI should have like very clear demarcated boundary of where it lives and what it does in your whole software development shop, right? And if you think of CI as just the orchestrator, as the guy who knows what happens when a software developer checks in and what happens when the build finishes, you are going to be a lot flexible and redundant in terms of your entire workflow. And the second is package and version every damn thing, right? Everything that goes into your version control. First of all, I forgot to put this point in. Everything should be in version control, right? Every single script that we are writing, every single script that you think are going to be useful, should be in the version control. Uh, you know, I've seen like like people writing release process in Word documents. If you're doing that, it's fine, but check them in the version control as well. At least like the next step would be we'll think about like moving them into like scripts. But yeah. Uh, but yeah, package and version everything, because if you are going to be like if you want to deliver fast, if you want to deliver every day, if you want to deliver every hour, if you want to deliver every half an hour, you need to know that you need to be able to track, right? You need to be able to track what you are building and what you can deliver, right? A continuous delivery is all about like the deltas, right? It's about like going from A state to B state and getting the delta of B minus A into production or into a system, into an A environment, right? So if you don't version, you are not going to have that capability, right? And version control is not the place for versioning your artifacts. Version control is a place where your software lives and not where your artifacts live, right? If you do that, you are going to be ending up with a huge version control SCM repo. And I've seen like people checking in binaries and stuff. It's going to lead into like, I've seen, in my opinion, it leads to like less of developer productivity, because it takes longer time to check out, right? Anyways, I mean, version everything and put everything in a repository, package repository. And after you have built your software, don't use the build tools, right? If you are using Rake, like the Ruby on Rails developers would be like cursing, because Rake is like the bread and butter for like launching the servers in the Ruby world and like doing everything. People use Capistrano, and Capistrano hooks into Rake, and people like to put everything in the Rake file. But in my opinion, I have seen whenever you treat your build scripts as the controller which can do stuff in your environment, it gets coupled to your developer's environment, because the primary people who are using the build tools are your developers, right? They are going to be doing some tweaks in your in your build tool which sort of helps them, right? which sort of helps the team to cut some corners and get something out on the fast, but that might not be the right way when you are deploying into a production system, right? So your scripts, or which you are going to use to deploy an artifact into your systems, should be outside your build tools and should be packaged with your the software that is going there, right? This leads to like a clear separation of what lives where, right? And it introduces a lot of discipline, and it introduces a pattern, right? And that pattern enforces people to think about how this software is going to be deployed, right? Very often, right, I've seen in build scripts, people before running a server, people run all the migration scripts, right? Now, do you really want to run migrations all the time in production? Right? You will want to run migrations, but you will know like when the database changes have to be applied, right? They don't have to be applied every time. If every deployment on production needs like database changes, then probably you are going to be deploying very less, right? And I've seen most of the times when deployment times are less, deployment is easier. People tend to deploy more. Like it goes hand in hand. Divide and conquer, right? As a consultant, I see like people from product companies like try to sell products which they claim that is going to solve all the problems of your organization, right? Some people say that I'm going to sell this release management software which is going to take all the pain out of your release management. Some people say that, oh, we have this automation tool, it's going to make your team it's going to introduce DevOps in your organization, right? People sell products to sell you things like, things which are just philosophies, right? So I think what has helped me in the past past couple of projects to think about like what is the problem that I am solving, right? And what are the pieces in the projects? What are the pieces in the puzzle that can be solved by a tool, right? What is the best tool that solves a problem, right? For example, configuration management is a problem, is one of the pieces in the puzzle. There is a problem in the puzzle about running commands on clusters, right? There are things like storing packages. There are problems around distributing keys, right? Distributing keys in your infrastructure. Now, how do you do them, right? Now, my philosophy is to understand each of these problems and see in the problem space which tool solves them and which tool does only that thing, right? And what I do then is like use all these tools and create and solve the bigger problem, right? The last is thinking hard about what are the pillars of your infrastructure. What I mean by that is if the data center goes down and say if you lose all your nodes, if you lose your entire data center, what is that one piece of infrastructure that can do a ripple effect and bring up everything else in your data center, right? For example, for me, it's my package repository. If I lose my package repository and if I don't have my artifacts, I can't bring up my current system, the infrastructure on which I am working. For me, the Jenkins server is not my infrastructure, crucial piece of infrastructure. For me, the tools, the logging server is not my crucial piece of infrastructure. But if I have the artifact repository, my Yum repository, I will get a package of AWS tools. And if I install the AWS tools somewhere, right, a blank machine, I can spin up other AWS machines. And in those AWS machines, in those instances, compute instances, not AWS, it can be Rackspace Cloud or whatever, your private data center, I can install the software that my team is writing. So what I consider to be the pillars of infrastructure is the center of if you call it like a whirlpool, like what is the center of the whirlpool? What is the thing that can ripple other things out, like bring up other things? And this also tells you, if you have something like that as something which is central, this tells you that that you have a point from where you can go and like scale out, or you can set up everything, even if you know shit hits the load balancer. Yeah. Now, as I said, I'm going to go through like Jenkins, Puppet, and Mcollective today. So the first, does it make sense? Like any questions so far? Like I don't want to wait till the end. Like if you have any questions, like just feel free to ask. And as I said, this stuff might not work for you, and also like would be good if you point out what won't work for you, so that like we can have a discussion then of what are the patterns that you might be observing in your organization, right? And everyone's infrastructure is different, and that's why this stuff always doesn't work in all the places. So Jenkins, right? How many of you have used Jenkins or heard about Jenkins? Pretty popular, right? Jenkins is a CI server. It's started as Hudson. Then some stuff happened when Oracle bought Sun, and the rest is history. We call it Jenkins now. So with Jenkins, some of the I'm going to share some of the best practices, some of the recipes that I use when I get onto a project. I always do distributed builds on Jenkins. What distributed build means is that if I have an instance of Jenkins, I don't make my build run on that instance, right? I, at the least bare minimum, for my CD pipeline, I have a Jenkins master and other Jenkins slaves, right? The reason why I do it is when your developers are checking in 50 commits or 60 commits a day, when they are doing like 5 commits per 5 minutes or 10 commits per 5 minutes, and it usually happens in ThoughtWorks projects, developers are crazy in checking it. They write one test and change one line and they would check it, right? And the entire software will be built. Right? So this is like this is our daily life, right? We see a lot of check-ins. So what happens is if you are running builds on the master becomes slow, right? Because remember, Jenkins is something that we are going to use to drive our entire CD pipeline, right? Jenkins has to trigger the builds on the QA instances. Jenkins has to spin up new machines. Jenkins is basically the heart of our infrastructure, right? And if we want to make Jenkins the heart of the infrastructure, the CD pipeline, then we'll have to make sure that the master, the guy which does all this orchestration, can be very lean and has as much resources as it needs to do the other work, right? So distributed build means that we are delegating the responsibility of doing the actual builds to other machines which are slaves, Jenkins slaves. Shard responsibility of the build infrastructure. Again, Jenkins should not be storing all your artifacts. If you store the artifacts in Jenkins, then what you are going to have to do is, as I said, like for example, for me, my package repository is the central pillar of my infrastructure. So if I can't lose my package repository, I can lose everything else, but I can't lose the package repository. For me, if I use Jenkins to store all my packages, then I would have to back up Jenkins every night, so that if something goes down, I can still get a backup of Jenkins from my backup, and I can reselect Jenkins and get all the artifacts so that I can spin up other things. So yeah, I mean, understanding the limits of Jenkins. So Jenkins can do very well in terms of storing artifacts, and it's usually like we start off projects by storing everything in Jenkins, by archiving everything in Jenkins. But it's not a very long-term strategy. It's not a very good long-term strategy if you want your build and infrastructure to scale, right? Thinking, as I said, right, think about like what happens when Jenkins goes down. Like in my last project, because Jenkins was the CD pipeline, what it meant was if Jenkins goes down, the QAs won't be able to deploy a new build onto the QA instances, or I won't be able to promote a new build into my production environment because my Jenkins is not there, right? If Jenkins goes down, like that is like all hell breaks loose for our team, right? In that scenario. So what we did was like very simple. We made sure that there was like a fail-safe kind of a mechanism in Jenkins. Jenkins writes everything into something called as Jenkins home. You can set up like a it's basically like an environment variable that you set up when you spin up Jenkins, and Jenkins is going to write everything there. So if you have your Jenkins home visible to another Jenkins master, say if you are say if you have like 2 data centers, and if somehow you are replicating the Jenkins home into both the data centers, if the Jenkins master in one data center goes down, you are still going to have a Jenkins master which is going to be as real time as the other the older Jenkins which went down, and you are still going to be having like an backup, right? And you are going to be having a good backup, like as good as it becomes. I think CloudBees, if you are using CloudBees, they have a plugin to do that stuff. I did it with ClusterWare, but yeah, I mean it's possible. So you could do it with Jenkins. Doing fail-safe stuff in Jenkins is not rocket science. Jenkins Job Builder. If you use Jenkins every day with anger, you would be hitting the configuration page. At least I hate. It's about like like all our builds have like at least 20 different configuration, and and it's a lot of clicks, right? Like we don't like clicking, right? We don't like GUIs, right? At least like a lot of us don't. So so yeah, Jenkins Job Builder is like a plugin. Not a plugin. It's a software written by the OpenStack guys. OpenStack uses the Jenkins Job Builder to configure the Jenkins instances. What it means is you can have a YAML file, and you can like describe how the configuration of your jobs look like. And Jenkins has a REST API. So JGB basically uses the YAML file to talk to the REST interface of Jenkins and configure the jobs for you. And why it's a good idea is because a lot of times people in the team like they tinker with your build stuff, and they want to add a plugin and those kind of stuff. They want to add the Chuck Norris plugin because they want like Chuck Norris to be mad, or like like when your build is breaking. But like after every 3 days there is going to be some problem in Jenkins, some problem, right? Oh, the build is not working because we unchecked this button which was checked. And what happens? If you have JJB, you can even check in the YAML files into your version control. So there is no way that someone can change the Jenkins configuration without going through JJB and changing it in the version control. So you have like one source of truth. And my latest favorite, which I haven't got a chance to unleash it because no one has asked for it. That's the problem of being a consultant. People have to ask you to build stuff. You can't build stuff otherwise. And yeah, I mean, I can complain about Manish, but it's not going to help now. Dynaslave plugin, right? So Dynaslave plugin is written by the Netflix guys, Brian Moyles and Garrett. Yeah, so the Netflix guys wrote this Dynaslave. What it means is if you are at Netflix scale, or if you are at a scale where you have like 1,000 builds a day, right? Your entire engineering is using Jenkins as their backbone, right? You are going to have a ton of build. That would mean that at some point of time you won't be able to like provision as many Jenkins slaves as you would need to get all the builds in time, right? So what Dynaslave plugin does is it lets you create new slave agents automatically and register them with Jenkins, right? So what you could do is you could know like what is the rate at which new jobs are coming to Jenkins. If you see they're going above a threshold, you could use Dynaslave plugin and create new images, new compute instances, and have them talk to Jenkins and declare that, hey, I am your new slave, and I have the label of a Windows agent or a free BSD agent, and I have these capabilities. There is not a really good way in Jenkins to say what a capability of a slave is, apart from saying that, apart from labeling. I find the whole labeling thing a little clumsy, but yeah, I mean, basically, yeah, with Dynaslave you can create like dynamic slaves. Build flow plugin is again gives you a DSL for describing how your builds are going to be in a nice way. It's a groovy DSL. It looks nice, so you might want to use it, and it's less work for you to configure using the groovy plugin. The configuration slicing plugin and the job DSL and this last plugin, I think it's by Netflix again. So if you have like common things, like for example in all your packaging or build jobs, you publish your JUnit reports, for example, right? Say imagine you have like 10 such jobs, you'll have to go click on everything or copy the whole configuration to every job. With configuration slicing plugin, you can define that this is a slice, and the slice of this configuration is going to be looking like I want to publish JUnit reports, and you can say that this slice applies to all these 10 different jobs. So you basically define slices and mix them with all the jobs. Yeah, visible jobs that hasn't been built successfully for the last n number of days. What I usually end up doing in my projects is I write automation scripts, which basically disables jobs automatically for me. Whenever developers have like 10 broken builds, I disable it, right? Like at least the scripts disable it, so that like I don't increase the amount of stuff that Jenkins is writing onto Jenkins home. If you have a lot of stuff going on in Jenkins home, the time that it takes to spin up a new Jenkins also increases. And if you have stuff on AWS, like it all counts, right? If you are like deploying a build onto, say, you have 86 build and you want to deploy 86 build into production, you don't want those builds which have been deployed to production to be deleted by your automation scripts or whatever. So everything which gets to the end of the pipeline, I declare them as permanent so that I don't lose them. And yeah, love Jenkins every day. Like it needs a lot of love. If you don't like pay attention to it, it's like it's going to like break away eventually, right? It's going to come back to you and say that I am not going to work for you, and your whole team is going to look up to you. Hey dude, where is my Jenkins instance? And it happens. It has happened so often that I'm not kidding. Like you need to pay attention to Jenkins every day, right? Like because it's your backbone, right? That's it. Yeah, that's about Jenkins. So next is Puppet. Right. How many of us here use Puppet or Chef or CF Engine? Okay. And any other kind of configuration management tool? Okay. Yeah, I think. What do you use out of curiosity? Octopus. Ah, the hipster. I'm kidding. Yeah, I mean it's good. I mean, yeah. I would, yeah. Yeah. It's yeah. I've heard stuff about Octopus, so yeah. I want to try it out. Maybe we can catch up later and talk about it. So yeah, I mean I use Puppet. I use Puppet. I love Puppet. Puppet has been around for a long time. The reason why I use Puppet is because I think it's very culturally aligned to the sysadmins, like traditional organizations. Because Puppet has been around for a long time, and I have found that it's easier for people to pick up Puppet than it is to pick up Chef, because Puppet describes what like the state of your system should be. Like it is a very descriptive language. You are able to describe like what is the end state of your system. You basically say that in my system there is going to be a file in /var/ something, right? Or you are going to say that in my system the end state should be that my firewall should not allow any clients on any other port apart from port 600 or something, right? So you describe what you want it to be, and then Puppet sees what your current state is and then applies the configuration based on what the current state of the system is and what the state of the system is that you want to, right? I forgot something that I was going to say. And the other good thing about Puppet is it's supported on a lot of various different platforms, including Windows. I've been said that it works on Windows. I'm not sure, but yeah, it works on almost everything, right? And the open source version works the enterprise version works on lesser number of systems because they don't support it on everything, but the open source version pretty much works on everything. So these are some of the things that I found useful when I do Puppet. I use Puppet as nodeless and masterless. So Puppet usually, like the documentation, like it promotes this master slave or master agent kind of way of doing things, where you have a Puppet master and you have Puppet agents all around your infrastructure, and then Puppet master pushes changes into your agents. I found this a little stiffening because most of the systems that I like to design, I like them to design in such a way that infrastructure can come and go, while as service should always be up. And in that way, like I find the clients, if I find it more easy to build such systems if my client knows what the intention of the client is, or what is the, what this client is supposed to do. I'll get into like what nodeless Puppet means in the next few slides. Uh, uh, and I like the reports that Puppet generates to feed into my metrics, into my visualization tool, so that I understand, like with every check-in that I'm making in my code, in my Puppet code, how my infrastructure is changing, right? If I'm changing, if I'm changing the configuration of IP tables, I should see in the graph of all the changes that I've made in the last 1 month, and how frequently I'm changing things, or how less frequently I'm changing things. All this can give me different meanings about like the kind of place where I'm working at, and or it gives me an understanding of how my environment is, and over the time that intelligence helps a lot. Fact-driven Puppet, and what fact-driven Puppet means is so there is the implicit, or like the more traditional way of using Puppet is you say that this is a host name, and this host name should get A, B, and C and Z configuration, right? You say that the host name is database o1 dot whatever, and this should get like a MySQL module. It should get like a some other module. I find that very limiting, because then I start treating my compute instances as human beings. I start treating my compute instances as a entity in my whole infrastructure. Whereas I like to think of my infrastructure as a collective, where I will have database servers. I'll have 10 of them or 15 of them depending on my needs, but they have to be exactly identical, right? I like all my infrastructure, a group of infrastructure, to be exactly identical. So what fact-driven Puppet means is, based on the facts of an instance, I get to apply the configuration, right? Based on what the fact is about a particular instance. Does everyone sort of like get what facts is? Because that is sort of like the central theme in the whole doing nodeless and what is it? Fact-driven Puppet. No? So okay, so Puppet has this thing called as Factor, right? Factor is a library, and it comes under the whole umbrella of Puppet. It's like a very integral part of Puppet. What Factor does is it exposes facts about your system, right? Let me see if I can get into one of my instances. Yeah. Oops. Right. So these are the facts about. Does everyone see? Okay. Right. So these are the facts of a system, like uptime days, uptime hours, like up time zone and swap free and all this stuff. Things like what is the CPU architecture, things like what is the host name. These are all facts of a system, right? So Factor is a library. It's a Ruby library which exposes all the data that your system has, which identifies the system, like what is the CPU, what is the CPU, what is the processor architecture, what is the, like how many disks you have, or anything related to your instance. factor basically pulls up all that information and exposes it to Puppet. It exposes it to Chef as well, but yeah, I mean, yeah, since we are talking about Puppet, we are only going to talk about Puppet here. In the context of Puppet, so factor basically exposes this stuff to Puppet. So what I do is I write some additional facts, right? What my additional facts are, it's like this, right? If I provision 5 new database servers, I have written like a custom library which extends factor to sort of read a file in my instance, which has the information something like role equal to database or something, and exposes the role equal to database as another fact. Instance underscore role as something like MySQL, like database or something, right? What this means is, by knowing this fact, what is the type of the role of an instance, I can then know what kind of configuration I need to apply. Does it make sense? No? Okay. So it's basically, so my philosophy is to not think of infrastructure as host names. The moment we start thinking about infrastructure as host names, we sort of try to say, oh, this guy is slow today, right? This guy is doing a lot of stuff. I don't want that. I want to say that all my database servers are slow, or 50% of my database servers are slow, or 70% of my database servers are slow. I don't want to distinguish between a database server than the other 4 or 100 database servers that way. So facts are a way for me to tag a instance and say that this is what the this is what life's goal is for this instance. I think Jordan Cecil of Loggly has written a wonderful blog about fact-driven Puppet, and it's in his blog semicomplete.com or org. I don't remember. He has written about nodeless Puppet and how he uses it in Loggly. The other stuff is masterless Puppet. I try to avoid Puppet Master. Puppet Master is the guy which sort of like is used traditionally, where you basically push configuration into your slaves. And with Puppet Master, you need a lot of infrastructure. You need to have like Nginx or Apache serving Puppet Master, the Ruby application, which is Puppet Master. And you need to think about SSL certificates and those kind of stuff. I do all masterless Puppet. What it means is, whenever developers check in code into the repository, into my SCM, I build a Puppet package. With every check-in, I build a Puppet package, and that I distribute that Puppet package whenever I have to provision. And that package itself has all the configuration, which reads the fact of an instance and applies whatever is needed. The last one is decouple data. A lot of places, like I see people put passwords and all other stuff into manifests. That is not to be done. Your data in Puppet should be in a store config or XTdata or HIDA. RI has, HIDA is pretty good, and that's what I use these days to have data out of my Puppet manifest and have them in some kind of backend. And HIDA has pluggable backends. That means if you are sort of like storing all your data related stuff of your infrastructure, say in Cassandra or React or something, you can write like a HIDA plugin which will talk to React and get the data out. Nodeless Puppet, right? Mostly, like you will see in Puppet manifests things like this: node web server 01.foobar.com, and then you will see like hundreds of configurations applied. For me, it's this node default. That means all the node gets this truth enforcer, right? This truth enforcer is a Puppet module that I have written, which basically enforces truth. Someone just said the other day that my module sounds more like a superhero from a comic book. I didn't meant it to be like that, but yeah, I mean, it's what its job is, right? Again, Jordan Cecil has written a blog about it, and he has some code in his repo which shows how truth enforcer should be. And so basically, what truth enforcer does is truth enforcer reads all the facts and applies all the configuration. As simple as that. It's a very simple thing. If it's like a front end, if it's like, do I have slides which describe slides? Something like this. truth enforcer looks like this. If the role of a server is web server, then it includes the front end manifest, the front end configuration. If the role is the CI, then it includes it applies the configuration that belongs to CI, right? So what it means is the same Puppet module that you are writing, or the same Puppet artifact that you are building can be distributed across your infrastructure, and based on these types, you are going to be getting a web server. You are not going to get web server 01 dot something, right? You are going to get a web server. Yes, it's going to have some host name or something, but the configuration, you will be less assured if you go down this route that all your web servers are going to be looking alike. All your database servers are going to be looking alike. Every project where we use Chef or Puppet starts with this thing that we are going to do, we are going to do infrastructure as code and all that. All our configuration is going to be managed, and we are not going to let all the configurations diverge. But after 3 months, like at least 40% or 30% of configurations diverge, because this database server is slow, so let me take this thing out, so let me add another configuration into it. But with this way, like you will be rest assured that you're going to have
Where do you store the roles of a fact?
Yeah, so this is something that I'm going to discuss. So that is, I think, the interesting bit. So what I usually do, I have a file in etc whatever, and I say that roles.txt or something, and I have written a custom Puppet function, parser function, which reads that file and which exposes that as a fact, uses factor to read what that thing is. So this has role is basically a function. It basically reads that fact, which which I get from that file, and that this has role returns you a string like CI or something.
How do you push that file? Is it
so I'm going to talk about when I talk about AWS. So it happens when you're doing a new instance. That's when it happens, and it's actually like sort of the secret sauce kind of thing, like, to do with this stuff. You can even put it manually, like it depends on your infrastructure, like it totally depends, like how you want to do it. Mcollective, right? Mcollective is like one of the stuff that I really like, and it has caught my imagination when I started doing this stuff. It basically lets you, as the name suggests, it's called Marionette Collective. It basically lets you treat your infrastructure as a collective, instead of treating every single machine as its own entity. It lets you group machines. Okay, so a pop quiz, right? How many of you in your organization have a shell script which manually serially SSHs into all the machines in your estate and does something? You have that, right? What does it do? Okay, so yeah, so basically, like, there are things like this, right? Like I've seen like things like this, right? There is a shell script which basically goes to all the machines in the estate and sets something related to NTP or something, right? What it does is what it does mean is, even with SSH multiplexing and stuff, you will be like taking a lot of time to finish it. And if you are looking at a scale of 1,000 machines, or 300 machines, or 2,000 machines, then you'll have to treat your infrastructure as a collective, right? You're going to have like servers in groups, right? You're not going to have like one single piece of infrastructure. The SSH stuff scales, but not beyond maybe 15-20 servers. With Marionette Collective, you basically get to treat your infrastructure as collective, and how these two things are in the same collective would be determined by the fact that is there, right? So if you have a fact in that machine, like role is dev machine, or role is nginx, or role is database, then all the machines with the fact of a particular role can be grouped as one collective. And again, how you do your collective is also up to you. Like Marionette Collective doesn't sort of impose on you like how you do the grouping and all that. It has got nice filter commands. You can do things like this. you can do things like this. You can say MCO package dev server install full Puppet 86. That would mean all the machines which are dev server, this package will be installed, right? A very common usage. I can explain a very common usage. We all do like web servers behind a load balancer, right? We have like 20, 30, or I don't know like how many web servers behind a load balancer. Imagine you want to restart your application, restart your application in 15 different places, and you want them to go down, the service to go down and go up at the same time, or almost at the same time, right? Imagine doing that at a huge scale, right? If you have something like this, MCO service, restart whatever service, it's going to be really easy for you, because then you can basically apply this command and you can be assured that it fans out to your infrastructure and does what you want. So Mcollective has this concept of plugins where package is a plugin and service is a plugin. And there are ton of other plugins. You can write your own plugin if you don't find a plugin that suits you. For example, in our project, we had to write a plugin which basically applies Puppet, right? So whenever there is a new build happening, we would want Mcollective to reach all our infrastructure where we want to deploy from our CD pipeline to go and run Puppet. So for that, there was no plugin at that point of time. I think they're coming up with some plugin now where you can do like long running jobs, but at that point there was nothing like that. So we wrote a plugin because it suited us. Any questions? There are like ton of like stuff that you could do with Mcollective that I think is just like sheer by the sheer amount of scale was not possible or was complicated. If you want to restart all the servers in the US, if you have data centers in US and UK, you could do that. You could filter the database servers in US. You could filter what is it? Yeah, AWS. This stuff that I'm going to talk here is not limited to AWS. It can be your any data center. It can be your private data center or Rackspace Cloud or anything. Basically all I wanted to communicate is if you have infrastructure in your data center, at least I try to make sure that I treat them as a service. If you have like vCenter or something, you can basically like you could potentially script them and say vCenter to give you a new instance or something. But with AWS, it becomes really easy. You get the Ruby or the Python SDK and you can say AWS give me this number of instance. Because I believe that treating infrastructure as something which is driven by code is useful, because then I know what is the state of infrastructure, because I know the code that has been checked in. I like thinking of infrastructure as immutable. I like the fact that I can say that after 20 days, if I take this server down and if I reselect a new server, that new server is going to be exactly like my older server, right? So that kind of stuff is possible if you are like doing everything using Puppet or Chef or CF engine. But this stuff, saying that your infrastructure is immutable, gives you immense power. When your data center goes down and your data center comes up, you will be rest assured that with a particular build of Puppet, you are going to get exactly the same kind of infrastructure that you had earlier, right? And this is very, this is very useful in a lot of cases, right? You can pinpoint bugs to a specific version of your infrastructure code, and I find that very useful. Make instances join the collective instead of you spinning up a new, instead of you forcing an instance to join the cluster. I like the other way around. So to give you an example, what I like is whenever people are making requests to my website, and if the load balancer sees a spike, I like the monitoring system to understand that there is a spike, and I want the monitoring systems to tell Jenkins that I need a new box, and then I want to run a job in Jenkins, which basically spins up a new compute instance, which runs Puppet and joins the load balancer. So basically on Christmas evening, I don't want I want to auto scale basically. Like this is basically nothing but auto scale, but I don't want to pay Amazon, or like if I am on my private data center, I would not not have auto scale just because I am not on AWS. It's very much possible to do what Amazon does on AWS with auto scaling in your own data center with just like normal vanilla technologies. Like it's no rocket science. You just need to know. You just need to monitor your load, and you need to have like tools which spins up new machines, and you need to have tools which provisions those machines. That's it. Now coming to the central theme, a continuous delivery pipeline using all these tools that we have seen so far. This is a pipeline that I saw a couple of months back. A typical pipeline at one of the software delivery houses. They had like code commits every night, and they had a nightly build, right? What that nightly build does is it compiles code, right, overnight, right, and at 7 o'clock someone comes in and deploys the code in the QA systems, right, and at 10 o'clock, and he comes early so that he can deploy by the time developers come in, right, and after every 15 days he does like a clean build, right. What a clean build means is he is going to take in all the chickens in the last 15 days and compile everything, and I think he used to deploy it again. I mean, I'm my problem is not with the process. I think I have some problems there as well. But my major problem is the hardship that these developers take on a daily basis to do their work. That is my real problem. That is my pain. Is the pain that the developers people that take to sort of work on their stuff, and this happens because of a pipeline like this. This happens because the pipeline is forking in so many directions, and whenever a pipeline forks on so many directions, it tells you invariably that there is some chaos happening on the shop floor, right? Just by seeing the pipeline, just by seeing how many branches in the pipeline, you will be able to tell how good the organization is at delivering software. Just or not good, like everyone delivers software. Actually, I should rephrase it. Or how efficiently an organization delivers software just by seeing their process, just by seeing the process by which they ship their code. So yeah, the pipeline that I kind of like is this, where there is a linear pipeline, right? You have commit, and you have tests, then you package, you publish your packages somewhere, and then you deploy your packages to your development instances. As soon as the packages gets published, and then so that you run your test and see like whether your software really works on a system which is not your development machine. And I want this every time a freaking commit happens, right? I would want this to happen 40 times a day, right? To give the developers a feedback of how good the software is, right? And once that is done, I would want the QAs to be able to push a button and deploy to as many QA environments they want. And then I want them to test it and deploy to integration environments as many times as the business owner wants. The more you deploy to your systems, the more you will be confident about your whole process, the more you will be confident about your software, and the more fun you are going to have. I mean, seriously, right? Like writing code all day, and if you can't check in, like for me, like the biggest problem is like, when it's 5:30 and I have not checked in, right? Like I like checking in like every 5 minutes. So that that keeps me moving, right? At least, yeah, I mean, so yeah, I mean, this kind of linear pipeline says that there is less chaos in your software development flow, and the less number of chaos there is, the lesser the chaos is, you are going to be able to deliver more, right? So if you go back and think of what your pipeline is, if you think what your stream looks like, you will know like how much fun you have when you are writing code. This is like, so I'm breaking this down into, okay, I have the sticker, I'm not using it. So this stuff, like I'm going to break it down of like a typical pipeline that I use in my projects is like this, right? Developers and ops, sysadmin people, like they all check in code in the same repository. The sysadmins and the developers, and the awesome DevOps people, They all should check in everything in the same repo, and basically like everyone should see each other's code, right? Developers would see like how the IP tables configuration is, and developers would see like how the scripts has been written, which launches their software, how the housekeeping scripts are, so that they know like how much resources they are writing into the disk and when they are going to be cleaned. So this is all like a good thing. Like everyone sees everyone's code. They all get an understanding of how things work. So they all check in into SCM, and then Jenkins basically pulls the SCM and builds it, right? And whenever Jenkins builds, right, what I want from my Jenkins, first step of Jenkins is artifacts, right? If you are on a RHEL-based system, if you ask me to deploy software on RHEL, I would want everything that Jenkins does to be packaged in RPMs. If you want me to deploy on Debian, I would want everything that Jenkins produces to be debs, right? Because if I'm deploying on a RHEL-based systems, getting RPMs gives me a lot of power. Then I can have all the install scripts and all the like things like what happens when you install, like you start up a service, or you make sure that a check config has been made, or a service has been a service is there in your rc.d. Like all that stuff can be encapsulated. The whole idea of encapsulating state in object-oriented programming very much applies to infrastructure code, right? If you are encapsulating everything, that would mean that there is less chaos in your artifacts, right? If you have one script doing something with another artifact, that means that there are still some problems going on in your stuff. So basically, what it does is it uploads it into your package repository. How am I doing with time? I think I'm pretty much out of time, right?
You have like about 5 minutes.
5 minutes for call. Okay. Fine. So I publish everything into package repository. So there are a lot of problems here. There are a lot of challenges here as well. And but yeah, this is typically how I like doing it. And then I have like the next state of my deployment pipeline to deploy to dev. Basically, what this does, again, this deploy to dev would be just a job in Jenkins. But what it would do is it will use Mcollective to sort of spin up a new instance, or its own instance. It would use some tools to spin up a machine, and then it would use Mcollective to install the foobar puppet, the stuff that I have that Jenkins has just produced, which it fetches from the package repository, and it would do a sudo puppet apply. And when you apply the puppet, basically what puppet would do is puppet would bring everything. So if foobar puppet is the package that you install, I would expect foobar puppet to install the other software that you would need to deploy your application. If you have a web application, foobar web app RPM, I would want puppet, the 86th version of puppet, to install 86th version of your web application, so that way all your releases have one version number. Package repository, right? So in this whole step, we are seeing Mcollective plays a good amount of role into fanning out and doing stuff, and Puppet plays the role of, or any configuration management tool plays the role of provisioning them. And then there is this whole thing about package repository, right? There is a lot of challenges around doing package repository. It's like whenever a build happens, you will have to upload a package. You will have to serve the packages to your entire infrastructure. You will have to have archive strategy, right? If you are doing like 50-60 builds a day, and if all your RPMs are like 86 MB, do like 50 into 86 MB of amount of space, and you are going to be running out of disk space very rapidly, right? So you need a archive strategy for your package repository. So I ended up writing a lot of script to do all this work, right? And whenever you you upload a package, your package repository has to make the metadata. So if you are on a RHEL, it will do create repo, and if you have 2000 packages, it will take like more than 5 minutes on virtualized infrastructure. It would vary on your mileage would vary depending on your infrastructure, but for me it took like 6-7 minutes on a virtualized thing. And so then your package repository have to trigger a new build into Jenkins so that it deploys that package which it has now made available to the entire world to deploy that package into an environment. And also, if you're doing continuous delivery, you would want to get some statistics like how many RPMs are you creating, how many packages are you creating on a daily basis. So you need to write all that scripts, right? And that is where my open source projects come in. right? I have written this awesome tool called as Seli, and it's on GitHub, right? Apache license. You can grab it and forget who Diptanu is, right? No strings attached. So basically, Seli has a REST API where you can basically like curl basically Seli host or whatever it's, and then you can have repository name, the name of your repository, and basically upload this package into Seli. So you don't have to write that script which uploads. You can have multiple repositories in Seli. You can have like a repository for all your one project, and if you have like 10 different projects, you want to keep the repositories apart, Seli would let you do it. It comes with an HTTP server embedded, so you don't need like Nginx or something. I have written it in Go, the Go programming language by Google, which is rock solid, and it's sort of like doing good. Like I didn't. It's not like I'm using Seli to like launch stuff on like 1,000 machines, so I won't boast about it being like rock solid and stuff. But it's work on the amount of scale that I am on. I have to test whether it works. It has stats. It will give you stats as JSON. It will give you like how many packages did you upload in the last 1 hour, how many revisions of a package you have made, and it would let you tag packages. So I have this whole philosophy of doing something like this. Using like Olympic they have like this medal like silver, bronze and stuff. The more far my packages go, that means like my packages are better. So a package which didn't make the dev because the smoke test failed, like I give them like a bronze tag. The tag which goes to QA, I give them like a silver tag, silver medal, and the ones which go to production, those are like gold, right? So I don't want to delete all the packages which are gold, right? Because the gold are the ones which I have deployed. So I would want to go to a previous production version of my software if I want to. So Seli lets you tag packages and set your archive strategy. You can say that delete all the bronze artifacts after say 1 hour or something, but don't ever delete all the gold packages. Something like that, yeah. And Seli can trigger once a package has been uploaded and the repo data, metadata has been created. Seli can trigger a custom URL. So yeah, I mean that's about my talk actually. And in the closing, it's all about like automate everything, measure everything that moves. Think about your infrastructure as a collective and not as like an individual being. Like they are machines, they are supposed to be like treated like that. Your CD pipeline should reflect your workflow. If your CD pipeline reflects your workflow, then you will know like where your workflow is convoluted, and you can fix those particular points in your workflow and make them a linear kind of a thing. So I think the whole pipeline on Jenkins, if it reflects how things work on the real world, like it sort of makes things easy. That's it. Thank you. Questions?
You know, you say you actually get your like QA team when you've done things to push it to print. What actual tool would you actually use for how do they have some sort of script that you've written, or would you tend to use something that
Right.
So actually say I want this specific build to actually go?
Yeah, I unfortunately like I can't show you anything because most of this stuff that I have I write it for our clients. I can show you, but basically Jenkins has this plugin called as the build pipeline plugin. In build pipeline plugin, you see like a box in your pipeline in every stage. So the QA stage is nothing but a box, and it has a button. So the QAs in my team push a button and they get like a new system. So all the QAs have to do, or if you are the product manager, then you just need to click a button to deploy onto production. That's it. And yeah, I mean there are scripts, right? Like that plugin doesn't do anything. That is like an interface for you to trigger a script which basically brings up a new issue. Yeah.
You package everything down, like source code, fairly easy. But got any tips on doing that in database, which is always
So there are a lot of different ways of doing it. Again, I would say that for comprehensive to have a comprehensive understanding, I think what is a book by Pramod Sadalga? I forgot. I think there are books around it. I think Pramod Sadalga has written some stuff around doing evolutionary changes, evolving changes in databases, where you basically make your database evolve over the time. So one tool that I have used in my project successfully is dbdeploy. So what dbdeploy does is it lets you version your SQL, and I have written scripts which basically takes the dbdeploy jar, and you can say that this is the directory where stuff is, and it basically applies the database changes. So your database changes has to be also scripted. If they are not, then it will be like a bottleneck. Whatever is not scripted is a bottleneck in automation. Right? Yeah. So I basically wrap dbdeploy with a shell script. So my dbdeploy stuff basically says, delta scripts create or run or something. Sorry? Yeah. That also goes as an RTM, yes. And all the configuration stuff goes into Puppet. So the database to which dbdeploy is going to talk is going to be managed by Puppet. It's not going to be in dbdeploy. dbdeploy's role is just to apply changes. That's it. Yeah.
It's a refactoring database system.
Yeah. Something else. Actually, no. Evolution. Something on that. Yeah, refactoring database is also a good place to start. Yeah, it's not refactoring database. Something else. Yeah.
So this role that you described, isn't that an ops role with some dev or dev role with some ops?
Yeah, so it's a very interesting topic, right? Like it's a very traditional thing, like dev versus ops. That's why DevOps comes, right? Dev loves ops, right? It's like this, right? So I think I totally get where you're saying, and it's a challenge for me on every project I get into. Sysadmins, first of all, they come from a different world, right? Their perspective is that they want to keep things stable so that things don't break, which is fine. And developers are very pushy, right? Developers want to push in every change they make into production or into some environment. And this sort of like kind of orthogonal to these two roles, the mindset of these two roles. So I think what helps is like if both this like set of people like sees the pain of each other, right? If you what has worked for me is to talk to sysadmins and explain them, hey, you know what, this is what we want to do, and there is no other way, man. Like, this is the only way we can achieve this. If you don't let us do this, then these are the implications, right? And we are going to consult with you, right? It's not, and the whole point is you are going to have a code base which is a collective ownership of sysadmins and developers. That is the key. If you give them commit rights on your database, say them that they are the people like who are going to configure the IP tables, then they are going to be happy with it, because like as long as you give them the power to sort of understand, right, like, or to at least tell you like what is important from their perspective, because they are the domain experts in that area, right? They have a lot of experience, like like they understand like the nuts and bolts, right? If you give them that that flexibility of doing what they want, and you also give the developers a chance to automate everything, I think it can coexist. But it's a major problem. I face it all the time. Yeah. 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 So I think you're talking about like how to roll out changes, right? How to roll out changes in production. Is that what you're saying? Essentially, like the theme, like when you have say 86 version of software, how do you launch like 100 version of software without affecting the service, right? Without having zero downtime, sort of. Right. So basically, I mean, in the past, like this is how I've done. Say I had to promote builds into production. What I did is, first of all, like my load balancer has to be programmable, or I should have like control over my load balancer. If I can't script my load balancer that I want 80% of the traffic to go into this and 20% of the traffic to go out on that, then it's not possible. So the solution that I'm going to talk about will essentially mean that you have control over the load balancer, right? So what I usually do is I start, I basically push like the new version of software on say 20% of the machine, and I make the load balancer push that percentage of users onto on those new machines. Oh, so as I said, right, in your so every time all the infrastructure code that I write has like a version number. They are no different from any other thing. If I change one configuration in Puppet, it will go into the SCM and it will produce a new build which will have a particular version number. Now in your CD pipeline, I am going to promote the 86 version all the way to the QA environment or pre-prod or whatever, right? When I know that this build is good, I am going to be promoting 86th version onto a particular set of the production machine, and that 86th version will have like a fixed number of changes or a defined amount of configuration, right? So the version number determines what configurations you have pushed in. Yeah. Exactly, and then you make your load balancer actually increase the amount of traffic that it sends to the new version. Facebook engineering has an awesome post about it, and their stuff is like awesome. Like they have like rings, so their stuff expands. They expands the stuff in the ring. So the more you go out in the ring, like the more servers get like the new version of Facebook.com. It's phenomenal. I hope, and I pray someone asks me to do it someday. Huh? Go. Go is a ThoughtWorks Studios product, and it's very good. And I think Bamdad's team uses it. And it's a good CI, and it has better pipelining systems than Go. Than Jenkins. But yeah, I mean, sorry. I'm going to be silent on it, but I think it's a good product. It's a good product. Yeah, it's a good product, and yeah, I mean, it's what's your experience? I think he's the best person to talk about it.
I tried Hudson before it changed the name to Jenkins, and I found Go much more flexible than that version of it.
Okay, so here you go. So here you go. So he says Go is more easy to configure,
especially on pipelining, as I said.
The pipelining stuff in Jenkins is not so good. I had to hack the pipelining process, and I got shouted at the ThoughtWorks CD mailing list about it. But yeah, I mean, so eventually it's going to get good in Jenkins as well. The Netflix guys have a plugin called as the build flow plugin, which is pretty good. It has a lot of promise. But the state of affairs in Jenkins around pipelining, right now you need to do something manual stuff. You need to write some Groovy scripts to pass down information of upstream jobs to downstream jobs, if you're using like a build pipeline kind of visualization system. But Jenkins as such is a solid CI server. I love Jenkins. I mean, no doubt about it. I like Go as well. But yeah, I mean, you shouldn't have asked me this question. Yeah, so any other questions? Yeah. That's just here, right? I don't say nodes. I just say that these are CI machines, these are database servers, these are web servers. I don't have node names at all. Those nodes actually joins a load balancer or publishes that they are present, So whenever I go into a project, I try to make sure that the system that we are building works in a very loosely coupled but coherently way, so that like we don't have coupling in between hosts and services. Then you can basically like make your application more robust. There is something called hysterics. You might want to check that out. It talks about like failover and stuff like that. If you don't like it, it's not directly related to nodeless puppet or something, but it's sort of like around this stuff where you say that you don't have you don't have like host names and as such. You have like a collective of services, which, and it's easy to make distributed systems where you don't rely on like host names and stuff.
You mentioned that you could replicate your own mechanism, like pushing something in AWS, without putting in check just getting used to it. So maybe you can have something like that, you can just implement that can reduce the runtime. So,
Yeah.
what if you're dealing with your VPC? How do you mitigate your risk of your connection to the VPC, for example? Do you put your CI into the cloud, or would you?
At least in my current project, the CI is in the cloud. In the public cloud, but you can, Amazon has security groups, right? So you can whitelist like the IPs that it's accessible from, and you are probably going to be natted anyways. Your organization is going to have a NAT or something, right? So you can specify in the security group that only this IP range can access your stuff. There are ways of securing it, but it's a public cloud, right? You'll have to secure it. Like you need to know like what are the points of stuff where things can go down.
Is a nodeless configuration achievable with Chef as well?
You know what? I don't know Chef. I can't comment on it. I have never used Chef. Sorry, I don't answer that. Thank you everyone for your time, and thanks Bandhat for giving me an opportunity to speak. Thanks. Yes.
So we will be in the crowbar. We can continue the discussion if anybody using stuff. Quickly ask for it. Right. Thanks.